Okay, in this class we are going to discuss R, and the title of this talk is R for MBA, and it's an introduction to the R programming language. It's a statistical programming language. It's a short introduction. It will just get you started with knowing what R is, how it came about, and how to use it. And there's a lot more to R that you will need to learn later on. So let's get started. So R was created by Ross Ihaka and Robert Gentleman in 1993 in the University of Auckland in New Zealand. And it's a programming language in which you write your commands and run. And before there was a language called S from Bell Labs in 1976. So R is a free version. S was probably not free. So let's get started. So you just, how do you look for, because R is a single letter, it's hard to Google for it. So you just say R stats for statistics, Windows for, because if you're installing on Windows, and download. You find R and also look for R Studio. It's just a nice UI. Then you install R and R Studio, download it, install it. Then once you install it, you'll get these icons. The version number may be different and the icons may look different on your Windows. And then when you double click on it, it will open up the R window or the R Studio window. So let's look at the Windows in detail. So we'll be mostly using R Studio, which is basically nice arrangement of windows. So R Studio consists of 4 panels, and in the first, this is the R Studio window, in which consists of file viewer, where you type in your edit files, and then in the next window next to it is the variables and values. These are variables and values. Below it is a console, the command prompt, and here is where you type in your commands, and the R interpreter will return the output. And this is where you will type most of your commands, almost all your commands. And if you have any graphs, it will show up on the panel next to it. And these panels are sub panels out here. You can say file, packages, help, viewer, and out here also the other sub panel like history. But these are the main panels will be working. So how do you start working in R? Usually you have some data to analyze. It will either be in Excel format or MySQL or some format. You will load the data into R. You will analyze the data, visualize the data into graphs, and come to some conclusion, and use the graphs and the conclusions in your papers or in your presentations. That's how R is used normally. And another use of R would be automating your data analysis. So first thing we need to know is help. If you're in R Studio, you can just say question mark, and this is the prompt, the greater than sign, question mark R unif. This stands for random uniform number distribution, and you type that, R will show you help on R unif, and you can read about it. Or if you are more lazy than that, also you can just type R stats RUNIF and Google, and Google also allows a spelling correction. So if you don't know how to spell random uniform, you can just write R stats random uniform, and you'll get the same result. You'll also get results from other places like Stack Overflow, which has really good reputation for answering exactly the answer that a newcomer encounters, exactly like you would encounter. Okay, so let's get started with R. You can use R like a calculator. You just say 1 plus 2 plus 100, you get 103. So this square bracket 1 is just this is a way of telling R that it's a vector of size 1. Then you can assign values to variables. So you're saying X, and this arrow, left arrow is actually 2 characters, less than and minus. 2 by 3 assigned to X. So you get X equal to 0.6667. So there's some digits of precision is there. It's not infinite. And Y equal to 5 by 3. Then Z equal to X plus Y. And then you press Z, it prints the answer, 2.33. So Z is here. All the variables that you assign are saved in the values in the environment, global environment. This is environment, and it's a global environment. And your history is also there, all the things you typed in, and you can also look at other stuff around. We'll look at later. Then you can plot the values. C stands for a column vector. So X, Y, Z are 3 values that you in a column you make it into a vector and give it a plot. So plots X, Y, and Z. X is 0.6, Y is 1.6, Z is 2.3, and 1, 2, and 3. So this is the index, and this is C, X, Y, Z. That's plotting. So it's like a calculator right now. You can also do scientific calculator, which is not easy a lot of times to do. Of course Google also does all the stuff, but you're going to use R for the time being. You can say 1 plus 1 by 2 plus 1 by 3 plus 2 by 3, and these are fractions. So R says 2.5 because this is 1. And okay, so one difference is that R allows for infinity and undefined objects. So you say 1 divided by 0 is undefined, so R says it's infinite. INF stands for infinite. And when you say 0 by 0, it says undefined or not a number. In computer science hardware, it's NaN. And also automatically uses complex numbers. Uses square root of 2i. It says 1 plus 1i. That's a complex number. So complex numbers, undefined numbers, infinity, not a numbers, everything is built into R. So let's look at a command prompt more. So you start R by clicking on this icon, and anything starting with a hash symbol is a comment. So from hash are ignored by R till the end of the line, and use hash, will use hash, and you should also be using hash to write what you're doing, because R is very cryptic and very condensed language. So you need to explain at the top of it whenever you're writing code what you're doing. So in this case I'm explaining to you 2 plus 2, and this is a comment, and the result is 4, and you can ignore the 1. That means 4 is the one vector of size 1, and similarly type anything, you get at 1 2.5. Let's see what are the other data types are there in R. So a lot of things are there in R which are not in other languages. Is the vector concept of vector sequences, which is heavily built into R. So sequence of numbers from 1 to 10 you would write like this, 1 colon 10, and if you write 1 colon 10 it prints 1 to 10. And then you could also create a vector using a C function, C1 4 0 minus 2, and assign it to U. And then 1 to 5 you write like this, C1 2 3 4, you could write like this. Or you could write sequence. Sequence is a function which starts from 0, ends at 4, and the length of the sequence is 3. The 1 2 3 numbers are there. Or sequence from 0 to 4 and incremented by 2 every time, 0 to 4. You can even name the elements of the vector A, B, C. A equal to 1, B equal to 5, C equal to 10. It's a name vector. So the first function we look at is summary function. So given an object U containing 4 elements, you say I want a summary of U. So then the summary of U prints minimum of U is minus 2. First quartile is minus 0.5. Median is 0.5. Mean is 0.75. Third quartile is 1.75, and maximum is 4. This is a maximum. So summary basically tells you whatever input you give it in summary of that. So look at the quantiles. So again, the quantiles of U are 0, 25, 50%, 75%, 100%. So it tells you what are the numbers that are quantiles, minus 2 to 4. And you could, instead of, if you don't like these percentages, you can give your own percentage, 0, 0.33, 0.66 and 1, and it gives you different set of numbers, quantiles. And then you can plot it also. So 1 is here, 4 is here, and then 0 is here, and minus 2 is there, 1, 2, 3 and 4, and U is on the y-axis. So and R has a lot of ways of plotting data, and we'll look at all the ways as we go along, and you'll find hundreds of ways when you search on Google of representing your data visually, and you'll choose one which is shows you clearly how the data distributions look very clearly. So boxplot is one way of showing. So you have this U vector and you want to show it, say boxplot U. So I will draw this thing. The minimum is here, the maximum is here, and these are called the outliers, and inside the pink box are the quantile 1 to quantile 3, and the median is a dark line. So median is 0.5 out here, and then summary of U tells you where this Q1 and Q3 are. Now the common thing used is a histogram. So histogram of U, it shows you the data of how many are between. It shows you at minus 2 to 0 there are 2 elements. Then at 2 there is one element between 0 and 2, and then one element at 4. So it shows a histogram. In this case it's not clear, but look at better example. When you have larger data it becomes clearer. Then we have many functions like mean. You have a vector, you can find a mean, standard deviation, maximum, minimum, median, variance, sum, length. The sum of U is 3, length of U is 4. standard deviation is 2.5, max is 4, min is minus 2, median is 0.5, and variance is 6.25, and mean is 0.75. We already saw NA and not available. So NA is not available. It's different from not a number. So let's look at example. You take string of log of a vector, and NA means not available. So what happens in Excel is, and other packages in programming, when something is not available, you just make it 0 or some -1 or something, and then when you do compute statistics, all your data goes wrong. It's like doing an election analysis or voter analysis, and all the people who didn't actually respond, you just put as the default vote, and then whole data is skewed. So in R is different in the sense that R actually tracks people who didn't respond as NA, that means not available. And so whenever you take average or median, NAs are not considered. So it's careful in using the means and averages. Suppose you take a sample of salary of like 1,000 people, and only 2 people respond, and you get an average of 1,000. That would be wrong unless you also tell the people that the sample size was only 2 people actually responded. So in this case we have this. So when you take log of -1, it's not a number. Log of 0 is minus infinity. Log of 1 is 0. Log of 2 is 0.693. This is log base 2. And NA is NA. So NA basically passes through functions as NA. And R will tell you warning that NA and not a number is produced. And you can check is finite or not. So you ask is finite. This is a function. Dots are part of the function. It doesn't really matter if you use dot or not. So this is a function with a dot name in the name. It says you give it this vector, it tells you false means it's not, it's finite. Log of -1 is not finite. Only these two are finite. And then dealing with missing values is a big part of R, which is not done in Excel. In Excel, really hard time dealing with missing values. So if you have a missing value in a vector NA, you try to take a mean, it says not available. So what you need to do is tell the mean function that na.rm equal to true. That means remove all the NAs. Then it gives you the mean. That means removing this thing. And then you can find NAs in X by saying is NA X. It tells you out here. There is a NA at this point. And the major part of R is also having all these random, fancy random numbers built into it. So let's look at some random numbers you could generate. You can say make 3 uniformly distributed random numbers. Random unif 3. It gives you 3 random numbers, so 3 digits. And if you want it between 5 and 10, you say between 5 and 10, 3. So it gives you 3 random numbers between 5 and 10. And then if you wanted to generate random numbers in a range with 1 decimal, you can just say round. Add the function round, digits equal to 1. You get 3 random numbers. And then what you could do is to save it in a variable y. And then you can see what's in y. And then you can let's look at a histogram with a larger set. You generate 100 uniform random numbers and save it in X and plot X as a histogram. So this is a frequency plot of X. Now let's look at normally distributed random numbers. Normal, so almost every distribution in real life is in physics would be normally distributed. We'll cover what normal distribution later on, but let's look at an example. So it says random normal 100, and then I want a histogram and a color equal to light blue. So 100 normal distributed random numbers, and then it shows you the histogram of 100 numbers, and the mean is around 0, and the standard deviation is between 2 and -2. So what you see out here is that call equal to light blue. This is a string you're passing to it, and this is a named parameter, because in R a lot of functions have like really lots of parameters, and you don't want to specify all the parameters to specify the ones that you're really interested in. You just have names for it, and in the beginning you get the default variables, and then you get a name variables. Let's look at another example. To roll a dice 10 times, how would you do it? You just say sample. Sample is a function which takes a vector 1 to 6, and I want to do it once, throw it once, you get one sample. And if you want to throw it 10 times, you say sample 1 to 6 10 times. What happens whenever sample doesn't really replace a number, so you tell sample to replace, after it takes out a number, put it back in the set of 1 to 6, so you get a sample, so that the number can repeat. Otherwise it will just sample new things. So if you say sample 166, you get a permutation of 1 to 6. And how do you toss a coin? You just create a vector of two strings, head and tails, and 10 times and replace equal to true. So true and t are actually synonymous for in R. And but not this t. This t is a string t for tail and head. So you get a bunch of 10 heads and tails. And how do you sample 4 students from a class of 54 students? You say sample from 1 to 54 and 4, and you want to replace it. That means I don't want to sample the same guy twice or same person. So I get 27, 5, 10, 29. So 4 people with no repetitions. Then what are the other things you can do in R? So let's look at an example of plotting. So you say X is a plot of random normal number, 100 random normal numbers, and Y is also X plus some normal numbers. So X and Y are clearly correlated, and then you want to plot X against Y. So you say plot X tilde Y, and then you get a plot like this. So this is called a scatter plot because they are points. X and Y are vectors. And then you can add a regression line, AB line, and you say linear regression on Y, X, and color is red. So you get this line. And then you can share your data with Excel, because a lot of times what people do is they have the data in Excel, they export it into R to process by R and get it back into Excel. Excel does have a lot of stats functions, and you can load packages into Excel to do data processing, but it's not scalable, and errors just propagate and without people knowing about it, because Excel just it's easier for Excel to not show you the error than to deal with errors. It deals with errors silently. So R will actually make you stop and make you think, okay, there's something missing out there. So how do you share with Excel? You say read.csv, and then file.choose is a function, and you choose a function. It will give you a pop-up, and then you pick a file and it will read it into a variable called sales. Or you could give it a string, the name of the file, and it will look in a current folder. You can also read SPSS data by using a library. It's a library for foreign data, and then read.spss, some SPSS file name. And we'll see later on how to process this variable after you read it in. So the most important data frame that's used heavily in R is the data frame. Data frame is like a Excel sheet. It has rows and columns, and it contains data in all the cells. So you say 3 columns A, B, C. So you make a data frame and assign it to X. Column A, column B, and column C. Column A contains 1, 2, 3, column B contains 5, 6, 7, column C contains 11, 12, 13. Then when you print X, you get this data frame. And to address only one column out of the whole Excel sheet of this data frame, you say X data frame $A. So you'll get this 1, 2, 3. And you could also address it as X double square bracket string A and close double square bracket. That gives you the column A. And you can delete a column of a data frame by just assigning null to it. So you can delete C. You can add a column by just saying $D and get another column. So you get A, B, D now with different data. And then there are many functions to combine sheets, data frames. So you have Y, which is 31 to 33, another thing. And you can cbind, column bind X and Y. So X is here and Y is here, and became a bigger data frame. And then in a data frame, the first thing you want to do is give a data frame with 1, X is 1, 2, not available, 4, X. And then you make a data frame out of it with Y is the reverse of X. So this is Y with reverse of X. But then this NA is, suppose NA is you want to remove them, you just say NA.omit in data frame D, and you get this row and the last row, and these two, the red ones got removed. And then another common data structure used in R is the matrix. So matrix, you give a bunch of values and you say number of rows or number of columns. So you're saying number of rows is 2. So it will say, and it's doing column major. So 1, 2, 3, 4. And these are the column names and these are the row names. And there are lots of functions. For example, determinant of a M would be 1 into 4 minus 2 into 3, which is minus 2. And next thing you can do is create your own functions. and we're going to look at later lectures a lot of details, but this is just giving an idea of what all R can do. So we're going to create a function called gamble. So you create a gamble is a function equal to function, or assign gamble is a object which is assigned a function, and the function is takes a variable n as a parameter, and it samples 1 to 6 n times and replace equal to true. Then after you define it, immediately you can call it. There's no need to compile it. You say gamble 4 and then n equal to 4, so it returns you 4 values, and then you can plot it. Also you say histogram gamble 100, color equal to pink, so you get this plot of histogram of gamble. And then because there's a lot of packages in R, it also comes with a lot of data. So let's look at some of the data so you can play around immediately. You don't need to actually have data, collect your own data. So let's look at some built-in examples. Now how to do it? You say example plot, and you see all the different plots. Example box plot, example histogram. You'll see different ways of doing it. And if you like something, you can stop and actually copy paste and use it in your own code. And there's a lot of data also. So typically if you look on Google, you'll find all these data being used to show different properties or features of R. So there's a library called a car, and the built-in data. It has every library has own built-in data sets. So you see scatter plot matrix, and then these are the parameters in the scatter plot data set: miles per gallon, displacement, DRAT, weight, cylinders, and data as empty cars. This is the empty cars, the data set. And then it will plot this stuff showing you that the relation between miles per gallon versus displacement and these are the data about the cars, engines. So it's easy to play around and try the examples until you find to understand that the features you're planning to use in your own R code. And if you're really not the coding type, there's something called Rcmdr, which also is a package inside R. You can download Rcmdr, library Rcmdr, and it has a lot of buttons for doing statisticals. But it's not as friendly as you might think, because you really need to know R to get things done. But Rcmdr makes it easy for you to not remember all the function names. It shows you nicely. But instead of Rcmdr, you might as well be using Google and Stack Overflow, and just type into Google, and then you find there are lots of complex ways of doing, hundreds of ways of doing the same thing in R, much more than even Perl. Let's look at more examples. You just say library Rcmdr, attach empty cars, and scatter 3D plot. You want to plot weight against displacement against MPG, and so it's plotting 3-dimension weight versus displacement and MPG of the car engines. And if you want to see more about empty cars, you just type question mark empty cars, will tell you more about it. Okay, this is just a short introduction to R, and if you're more interested, these are some of the free stuff available on the web. Introduction to R by Venables and Smith. It's part of the R intro manual. It's available online. Just type into Google, you'll find a book or whatever, the thick manual. And the stats method has some stuff, and all the stuff is taken from here. Advanced probability is statistics in R. There's a Zoonkind, is a guy who wrote this blog. He has a lot of interesting stuff. Unfortunately, some people consider it R rated and it's blocked in India, but it's just R code. Then statistics, UCLA is a lot of stuff, and several lectures on financial trading with R. And there's like lots and lots of stuff. It just depends on how much time you can spend reading it up or learning. And the best way to learn is by actually doing it. We'll look more later in the later lectures. Thank you.